Assalamu alaikum students. We have stopped last video on how can current mix electromagnet. Now follow me with these two figures. The first one, which is on the left side, is clockwise electron flow, while the second one is anti-clockwise electron flow. You see the first one, the flow of electron which is clockwise means conventional current. Look, it is conventional current. Here also anti-clockwise means conventional current. Otherwise, flow of electron is from negative to positive. From negative to positive. Look, so flow of electron is from negative to positive, while flow of conventional current is from positive to negative. We have discussed this in our chapter 3. Now, okay, our main concern here is the magnetic field. Okay, when the current flows, we have magnet. That means we have magnetic field. If there is flow of current, that is the electron, the important thing. So we have to follow the flow of electrons. Look, these lines, okay, which have north and south. North and south. What is the difference between these two figures? Can you observe the difference between these two figures? In the first figure, the current, okay, flows from this port to the above. In the second, from the above to the lower. Okay, so we will use two laws. Okay, two laws to know the direction of what? The direction of the magnetic field. So our important point here is direction of magnetic field. How you know the direction of the magnetic field? Either using right hand rule or left hand rule. When you use right hand rule and when we use left hand rule, we will use left hand rule if we consider electron flow or real flow. We'll use conventional, we'll use right hand rule if we consider conventional current flow. This is important. Okay, this is important. So now either of the laws we can apply to know the direction of what? The direction of our magnetic field. Direction of our magnetic field. Go to the next page. It says we can apply left hand rule. The left hand rule. In some books, for example in your textbook, they will apply right hand rule because they consider what? Conventional current. But if we consider real current, the direction of electron flow, we will use left hand rule. Okay, what left hand rule says? If your thumb shows the direction of current flow, if your thumb directs to the direction of current flow, so when you round the conductor, okay, your fingers will show, the other fingers will show, if you hold with your left hand, your fingers will show what? The direction of lines of magnetic field. The direction of lines of force or magnetic field, which is left hand rule. Which is left hand rule. Look, so between your thumb and the other fingers, the angle between the thumb and the other fingers is what? It is 90 degree. So its sine value is 1. Okay, remember, its sine value is 1. Remember this one, because sine 90 degrees 1. We will use this, okay, concept when we calculate the magnetic force, the magnetic force in the magnetic field. Because students, okay, keep in mind that in electromagnetism Our main purpose is increasing the force of what? The force of the magnetic field. That is the strength of the magnetic field. By that force we can do some work what we need. So the recognition direction of magnetic field is from north pole to its south pole. We'll know also by left hand rule the south and the north pole of the magnet. The south and the north pole of the magnet. How? In this way we'll come to the point. The position of the fingers across and around the conductor will now be pointing the direction of generated magnetic lines of force as shown. If the direction of electron flowing through the conductor is reversed, then the left hand will be reversed. This left hand route will be reversed. So that is why the two figures in the first page are different. One is reversed upward. One is reversed upward of the other. So the left hand rule, it says, can be used to determine the magnetic direction of poles, that is the negative and positive. This time what it says? This time the finger point in the direction of the electron. The other fingers show the direction of the electron flow from negative to positive. From negative to positive. Because now we are using what? We are using left hand rule. If we are using left hand rule, we have said we will consider which rule? Left hand rule. We consider negative to positive, which is real flow of currents, while the extended term in this case indicates the direction of north pole. Keep this in mind. So left hand rule can be used to identify the direction of magnetic field and the direction of the poles, south and north. How we use? We have discussed. Do you understand how we use our left hand to know the direction of the magnetic field? One, and the direction of what? Direction of the pole, especially the north pole. If you know the north pole, so the right pole, the south pole will be by default known. Clear? So the next page now tells you this variation of the rules. The right hand rule and the left hand rule is what? Is based on so-called conventional current, which is positive to negative. So right hand rule is based on conventional current and the left hand rule is based on real current. You know that real current flows from negative port to positive port. This was our discussion in chapter 3 of the last sections. So now the strength of the magnetic field depends on three different things, and based on this we will do calculations. Next time we will discuss these factors plus some given or solved examples. After that I will give you a question. See you. Thank you very much.